sinabi natin, tinitreat natin yung light as a wave, ibig sabihin, kinoconsider natin yung tawag dito, properties nung light na to as a wave. So in other words, yung wavelength or yung frequency or yung ano tawag dito, wave velocity, okay, yung intensity, and how waves interfere. So, diniscuss natin before, di ba, na pag meron kayong dalawang waves, these waves can interfere constructively or destructively. Okay? Very simply, kung yung waves ay in phase, they will interfere constructively. At ang mangyayari ay mag-a-adapt lang yung waves na yon. And pag yung waves ay out of phase by 180 degrees or shifted by 180 degrees, ibig sabihin itong waves na to ay mag-interfere destructively. Diniscuss natin ito dati, no? Tama? Tama ba? Okay. So, ang gagawin natin ngayon, or gagamitin pa rin natin yung concept na yun ng interference or constructive interference at saka destructive na interference. Okay, dito sa pag-aaral ng interference at saka diffraction. Ang basic assumption or yung condition para ito ay mag-occur, first of all, is that yung wave ay dapat monochromatic. Pag sinabing monochromatic, from the root word, it's mono, ibig sabihin single, di ba? And chrome, ibig sabihin colored. So, ibig sabihin single color or single wavelength. Okay, so it should come from a source. Okay, it should come from a source or two or multiple sources that have exactly the same wavelength. Okay? Pero sa physics, pwedeng isa lang yung source mo at pwede mong hatiin yung source na yon, okay, in such a way na magiging dalawa or tatlo or apat yung waves. Okay? So, halimbawa, okay, dito sa picture na ito or dito sa chapter na ito, okay, ng book. Okay, dito sa picture na ito, makikita nyo na mayroong monochromatic light, okay, na pumapasok sa isang slit. Okay, yung slit na yan ay may specific na size. And pag sinabi natin size, ang concern lang natin is not yung length ng slit, but yung width ng slit. Okay, so wala tayong pakialam sa length. Sa width tayo merong pakialam. Okay, and pag tumama siya dito sa slit na ito, ang mangyayari dun sa light na yan, okay, ay magpo-form siya ng waves. Okay, so dito, may papansin nyo rito yung wave na magpo-form niya. Okay, and after nung slit na ito, meron ka na namang second plate which has two slits. Okay, so now, you have two sources of light. So meron kang two waves. Okay, pero alam mo na monochromatic sila. Bakit? Kasi it came from a single source at ang ginawa nyo na para maging wave yung pattern dito ay naglagay ka lang muna ng single slit and pagdating dito or from here nag-form ka ng waves na spherical yung propagation. Tapos pagdating dito nagkaroon ka ngayon ng dalawang waves na again spherical yung propagation. Okay? So, assured kayo na itong dalawang waves na nanggagaling dito sa dalawang states na ito ay monochromatic. So they have exactly the same wavelength. Ngayon, ang tanong is, anong mangyayari kung maglalagay kayo ng plate dito sa dulo? Okay? O anong makikita nyo na pattern? Okay, now, this is a little bit more complicated kumpara dun sa simplistic picture na pinrovide natin before na pag meron kayong dalawang waves na in phase, mag-a-adapt sila at dalawang waves na out of phase, magka-cancel lang sila. Okay? Ngayon, it's a little bit complicated kasi kailangan natin i-consider kung ano nangyayari at each point dito sa plate at kung paano nag-interfere yung waves na galing dito sa S2 at saka sa S1. Okay? So, pwede natin gamitin tong picture na ito. So, here, you have two slits. Okay? So, ito yung isang slit. Okay? Yan, naklaro yung figure. So, ito yung actually, ito yung distance between two slits. So, dapat yung slit ay nasa gitna. Yeah. So, ito yung isang slit. Ito yung pangalawang slit. So, remember, meron kayong wave. okay, na nag-generate sa bawat slit na yan. Ngayon, sinabi natin na pwede natin i-represent yung wave na yan as a light ray, di ba? So yun yung pinapakita dito, pinarepresent as a light ray. Ngayon, pwede tayong pumili ng point dito sa screen. Okay? And titignan natin kung paano mag-interfere constructively or destructively yung waves dyan. Okay? Now, when we look at interference at any point P dito sa screen, basically, dalawang quantities yung gusto nating makita. Okay. First of all, how much out of phase are these two waves? Okay. And secondly, ano yung intensity ng waves na yon? So, for these next two chapters, yun yung basically isosolve ninyo. Ano yung phase shift or phase difference between the two waves at ano yung intensity as a result of the interference of these two waves. Okay? Yun yung idea. So, yun yung ito-try natin na i-solve. Okay. Ano ang itsura ng mga waves na to pag tinignan natin? So, kung titignan natin dito sa taas ng konti, okay, we can take a look at these two waves. Okay, imagine niyo na ito yung isang slit, ito yung pangalawang slit, slit 1 at slit 2. Tapos mula sa slit 1, yan yung wave, at mula sa slit 2, ito yung wave. Pagdating nila sa point B, okay, meron ng 7 na wavelengths, or yung distance from S1 to B ay 7 wavelengths. Tapos yung distance from S2 to B ay 9 wavelengths. Okay? Okay, which means na ang difference between yung distance from S1 to B at saka distance from S2 to B ay 2 wavelengths, or exactly 2 wavelengths. This tells us na itong dalawang waves na ito ay mag-interfere constructively. Right? Tama? Okay. Ngayon, if their phase or if the difference in waves is, sabihin natin 1.5 or 2.5, okay, ibig sabihin shifted by 180 degrees yung phase ng dalawang waves. Ang mangyayari sa point B is mag-interfere destructively yung dalawang waves na yan. Naintindihan niyo? Naintindihan niyo? O hindi? Hindi, okay. So, syempre, may measure natin yung distance na yan, di ba? Ang distance, tinawag nating R1 equal sa 7 lambda. Okay? Itong distance na to, tatawagin natin R2 equal yan sa 9 lambda. And yung difference in terms of distance ay equal sa 2 lambda. Since lambda, multiple values of lambda, yung value, alam natin na mag-interfere sila constructively. Pag titignan natin dito sa baba, okay, yung S1 ngayon hanggang point C ay 9.75 lambda. Yung S2 hanggang point C ay 7.25 lambda. Ano yung difference? R2 minus R1 equals to negative 2.50 lambda. Okay? Naintindihan nyo ba yan? Ibig sabihin ng negative 2.50 lambda. Ibig sabihin, dito sa point C, 180 degrees out of phase yung dalawang waves. Okay, 180 degrees na out of phase sila. Which means na sa point C, nag-interfere sila destructively. At wala kayong makikita kahit anong light dyan sa point C. Okay? Yun yung idea dito. So, mathematically, pwede natin isulat yung equation na yan, o pwede natin i-express yung kung mag-interfere sila constructively or destructively using a very simple equation. Okay? So, yung difference between the two distances is R2 minus R1. Okay? And in order for them to interfere constructively, dapat multiples of the wavelength yung distance na ito. Okay? So, for constructive interference, okay, R2 minus R1 must be equal to m lambda. Okay, where m is equal to integer values, including negative values. Okay? Now, if they are going to interfere destructively, okay, dapat yung difference R2 minus R1 ay equal sa multiples ng m plus 1/2. Okay, so dito papasok yung 0.5. M is also composed of integer values. Okay? Nakasunod? Nakasunod? Okay. So, ito ngayon ang ating unang, tawag dito, unang basic na equation. Pagdating sa interference and even pagdating sa diffraction. Okay, so R2 minus R1 okay, so R2 minus R1 ay equal sa m lambda for constructive interference. Okay, or equal to sa m plus 1/2 lambda for destructive interference. Okay, so basically this describes yung phase difference between the two waves. Okay, and kung titignan niyo ang phase difference na tinitignan natin dito ay 0 at saka 180 degrees. Okay, so hindi pa natin gine-generalize. Okay? Okay? Okay. Okay, so we can use that same mathematics here. Okay, the same mathematical treatment dito. Okay, so if you have two slits, from each of these slits, lalabas yung weights. Okay, at yung distance, okay, or yung difference between R2 at saka R1 dito sa figure na ito, if they are multiples of the wavelength, at point P, mag-interfere sila constructively. Pero if they are multiples in terms of m plus 1/2 ng wavelength, mag-interfere sila destructively. Okay? So exactly the same treatment in terms of mathematics. Okay, questions? Questions? Wala. Okay. Ang hindi ko nabanggit pala dito is that merong distance yung dalawang slits from each other. At yung distance na yun ay symbolized by D. Okay, ngayon, pwede tayong gumamit ng approximation dito. Remember na ang first assumption is dapat yung light is monochromatic. Ngayon, ang second assumption natin dito is that yung R na ito, which is yung distance na between this plate at saka yung position ng slits. Okay, yung R na ito, if it's very, very far away kumpara sa tawag dito sa Y, or kung ano yung position, yung Y is yung position ng point P relative to this point na ito, which is normal dun sa slit. Okay, if Y is very, very much small than R, then we can think of yung rays na to having this kind of ano tawag dito? Orientation. Okay? Ngayon, bakit ito mapapadali ng buhay? Kasi, okay, makikita nyo na yung dalawang rays ay parallel sa isa't isa. Okay, and if they are parallel to each other, okay, yung R1 at saka R2 is almost the same. Okay, remember mag-work lang to pag yung R ay malaki-malaki. Okay, it's as if the rays are parallel. Okay. And if they are parallel, yung difference lang between R2 and R1, okay, is this small distance na ito. Diba? So kung magdodrawing ako ng line papunta doon, okay, yung difference between R2 at saka R1 is this distance. Sunod? Kasunod. So essentially, dyan yung makikita yung phase difference. Okay? Nangyari lang yan dahil in-assume natin na yung R is very, very far away from the slit. Which means na yung dalawang light rays na ito, okay, ay parallel na sa isa't isa. Okay? So, pwede nyo imagine yan dito. Okay? Ngayon, magkalapit sila. Ilayo natin tong plate na ito. Okay? Ilayo pa natin yan. Ano sa tingin nyo mangyayari sa orientation ng dalawa? Eventually, sobrang layo ng R, sobrang laki ng R, or sobrang layo ng screen from here, na yung tingin nyo na dito sa dalawang lines ay parallel na sa isa't isa. Okay? Yun yung point na gusto kong palabasin dito. And in that case, ang difference lang between R2 at saka R1 is this small distance. Okay? So parang hanggang dito lang. The rest ay parang sila. So we will know if they're in phase or out of phase depende sa relationship nito dun sa wavelength. Naintindihan nyo? Sunod. Okay. Ngayon, paano nakuha yung d sin theta niya? Kasi ito, triangle yan. Form yan ng triangle. At ano yung angle na theta? Well, yung angle na theta is ito. Ayan. Ito yung angle na theta, which is angle with respect to the normal. Okay? Tama? Tama? So, ibig sabihin, yung angle na theta ay nandito. Tama? Okay? At ito ay 90 minus theta. Right? Right? Tama ba? Okay. So, ibig sabihin, using trigonometry, this is d sin theta. Kasi ito yung hypotenuse ninyo, ito yung adjacent to theta, at ito yung opposite to theta. Right? Right? So, how do we know if they interfere or interfere constructively or destructively? Yung difference, which is R2 minus R1, which is also equal to d sin theta, ay dapat equal sa m lambda, okay, for them to interfere constructively, okay, or m plus 1/2 lambda for them to interfere destructively. Okay, so ito yung sinasabi natin. Yung difference na R2 minus R1 ngayon ay equal sa d sin theta. And if they're going to interfere constructively or destructively, dapat equal sa m lambda for constructive interference or m plus 1/2 lambda for destructive interference. Sunod? Okay. So again, gumamit tayo ng assumption. Dalawa yung assumption na ginamit natin. First of all, that light should be monochromatic. And secondly, that the distance R is very, very far away. Okay, such that yung lines na ito ay parallel na sa isa't isa. Yung light rays ay parallel sa isa't isa. Okay? Questions? Questions? So, pwede na natin yung idagdag. Dito. So, d sin theta ay equal sa m lambda for constructive interference and m plus 1/2 lambda for destructive interference. Okay? Okay. Now, kung babalikan natin yung figure na ito, okay, if this is the angle theta, then pwede natin i-relate itong distance na y with r. Right? And immediately, makikita natin na tangent theta is equal to y over r. Right? Agree? Agree? Kasi ito yung triangle nyo. Mula dito, hanggang doon, dito, at saka yun. Okay? Nakasunod. Nakasunod. Okay, ngayon. Tataka kayo, no? Dito kasi, itong theta ba na ito ay pareho sa theta na ito? Yun yung sigurong iniisip ninyo. Okay, siguro yung isa pa ninyo iniisip is matagal pa ba bago mag-break. Okay, pero para sagutin yung una yung iniisip, again, if we use the assumption that R is very, very large, then this angle theta here is approximately the same as this angle theta here. Okay lang ba yan? Mathematically sound ba yan? Okay? Okay. So in that case, yung tangent theta ay equal nga sa y over r. Right? Right? Okay. Now, you can also see that if y is very small kumpara sa r, it also means that we're using small angles. And for small angles, we can approximate tangent theta or sine theta to be equal to theta. Tama ba? Tama? Okay, so theta ngayon ay equal na sa y over r. Di ba ang dali pag lahat ay merong approximation? I'm sure ginagawa nyo rin yun sa math, dun sa mga courses ninyo. Tama? Pero dito sa physics, marami tayong ginagawang ganong klaseng approximation. So ito yung isa. So ym is equal to r tangent theta. Okay, pero again dahil maliit nga dahil we're using small angles, yung tangent theta ngayon ay equal na lang sa y over r. Or approximately equal na rin siya sa sine theta. Pero kanina kakaderive lang natin na for constructive interference, d sine theta ay equal sa m lambda. Which means na ang sine theta ay equal sa m lambda over d. So we have this equation, okay, for the distance, okay, for y, which is the distance from the center hanggang dun sa point P. Kung saan tinitignan nyo kung may constructive or destructive na interference. Okay? Kasunod. Okay. Ngayon, yung nakita niyo experiment kanina, yung double slit na schematic or na setup, ang tawag dun sa experiment na yun is Young's experiment or Young's double slit experiment. Okay? Kaya dito makikita nyo na yung equation na ito corresponds to Young's or constructive interference in Young's experiment. Okay, similarly, pag destructive interference, you get y sub m. Okay, y sub m equal to r times m plus 1/2 times lambda over t. Okay, ngayon. Kung titignan natin dito naman, itong figure na to is actually yung figure na makukuha ninyo dun sa plate. Okay, so ito yung 0. So, ibig sabihin, ito yung nagko-correspond dun sa normal line. Of course, pag dun siya sa gitna, alam nyo na mag-interfere constructively yung dalawang waves. Okay, kasi, anong tawag dito? Exactly the same yung distance. Walang difference between R2 at saka R1. Kasi nasa gitna siya, symmetric siya. Diba? So dito, this is, this is automatically constructive interference. This represents a region for constructive interference. Somewhere in between is the region corresponding to destructive interference. At kung papansinin ninyo, as you move from 0 to higher integers, yung light ay nagdi-decrease ng intensity. Okay, so it is most intense dito sa gitna and it decreases intensity as you move or as y increases. So yung y is yung distance mula dito hanggang any point dito sa region nito. Okay? So your y can have positive or negative values. Kasi yung m ninyo ay pwedeng positive or negative values. Okay? Pero ang kinaganda kasi dito, symmetric siya. Okay? So if it is positive, pwede nyo, dahil symmetric siya, pwede nyo i-drawing yung upper half lang and then just, anong tawag dito? Copy-paste yung upper half para i-paste nyo dun sa lower half. Okay? So exactly the same behavior. Ang sunod. Okay. Now we can discuss an example. Okay, so for two-slit experiment, a two-slit interference. In a two-slit interference experiment, the slits are 0.200 millimeters apart, and the screen is at a distance of 1.00 meters. Okay, ang tawag pala dun sa sa mga lines na yun is a fringe. Okay, so pag sinabing third bright fringe, okay, ang definition niya dito is not counting the central bright fringe, okay, is found to be displaced 9.49 millimeters from the central fringe. Okay, so third, ibig sabihin, anong M value siya? Ano ba yung first na value ng, ano ba yung central fringe? Anong yung M value ng central fringe? 0. Diba? So yung first na fringe, okay, so kung bibilangin nyo rito, yan. Yung numbers na nakikita nyo dyan, yan na yung M value. So ito yung M equals 0. Ito yung first na bright fringe. Ito yung second na bright fringe. Ito yung third na bright fringe. So nagko-correspond siya sa M equals plus or minus 3. Okay. So, anong distance na yun? It's 9.49 millimeters from the central fringe. Find the wavelength of the light used. Okay, so anong equation ang gagamitin natin dito? Y sub M ay equal sa R times M lambda over D. Okay, so idagdag, bago natin i-solve pala, no? Dagdag natin yung dito sa ating listahan. So, Y sub M is equal to R M lambda over D. Okay, alam ba natin ang hinahanap natin ay Y sub 3. Right? Y sub 3. Ano yung R? Ang R ay 1.0 meters. Okay? Ano bang hinahanap natin? Lambda pa lang hinahanap natin. Lambda. Ano yung Y sub 3? 9.49 millimeters. So, justified ba yung paggamit natin ng small angle approximation? Kasi if you compare 9.49 millimeters to 1 meter, justified ba yung small angle approximation na yun? Yes. Okay? So, 9.49 millimeters ay equal sa 1.0 meters times 3, di ba? Which is yung M value. Okay, times 3 divided by D. Ano yung D? Okay. 0.200 millimeters apart. And then you can immediately solve for the wavelength. Okay, so if you solve for the wavelength, ang makukuha ninyo ay 633 nanometers. So, nagko-correspond siya sa visible spectrum. Right? Nandito siya sa banda sa red. Okay? Okay? Which is typical naman kasi ibig sabihin gumagamit lang siya ng red na laser. Okay, dito dun sa experiment. I think gagawa rin kayo ng ganito experiment sa sa 103.1 and ang laser lang naman na available is a red laser. Okay, so yan na yung wavelength ng laser. Unless specified. Okay, so ganito yung itsura ng setup. Ito yung double slit. Ito yung 0.200 millimeters. At ito yung M equals or yung third na bright fringe. Okay, questions? Questions? Wala? Okay. Okay. Siyempre, lahat ng physics na pinag-aaralan natin ay pwede nyo i-apply sa essentially kahit anong aspect as long as you're talking about electromagnetic waves. Okay. Tulad dito, now we're going to discuss radio station operating at a frequency of 1,500 kilohertz or 1.5 megahertz. Okay, 1.5 megahertz. AM or FM? Alam nyo na hindi yan FM kasi anong lowest frequency ng FM? Ano ang lowest frequency ng FM? Hindi, ano yung lowest frequency? Hindi nyo alam? Idadial nyo lang naman yung radio. Ano yung pinakamababang frequency doon sa ano? 80? 88? Meron ba? 88? 88? 89? Hindi nyo alam? Kasi anong frequency kayo nakikinig? 10? 103.1? Di ba yun yung laboratory class yun? Pero anyway, ang point is, pag denial down nyo sa pinakamababang frequency, yun yung lowest frequency ng FM. At pag nilipat nyo naman sa opposite end, yun yung highest frequency ng FM. So 107, 108 megahertz. Tama? And yung FM, yung lower frequency niya, if I remember correctly, is 87 or 88 megahertz. Okay? So ito, hindi pa ito pasok sa FM. So this is most probably AM. Yun naman nakasulat dyan. Near the top end of the AM broadcast band. Okay? So, it has two identical vertical dipole antennas spaced 400 millimeters apart, oscillating in phase. Okay? Ano yung sinasabi dito na antenna? Well, yun yung antenna ng AM radio station. Okay? Pero ngayon, mas magmumukha kayong cool or cooler pag sinabi nyo sa kaibigan nyo, hindi lang antenna ang tawag dyan. Ang tawag dyan ay vertical dipole antenna. Okay? Now you can have two vertical dipole antennas, okay, that are spaced 400 meters apart tulad dito sa problem na ito. Okay, at pag sinabing nag-oscillate sila in phase, ina-assume lang natin na monochromatic yung source. Naintindihan niyo? Okay, monochromatic yung source, and from the two antennas sabay or in phase nalalabas yung wavelength na yun. So at distances much greater than 400 meters, in what directions is or are the intensity greatest in the resulting radiation pattern? Okay? So anong frequency, anong direction sila? Anong tawag dito? Most intense. Okay? So sabi rito, this is not just a hypothetical problem. It is often desirable to beam most of the radiated energy from a radio transmitter in a particular direction rather than uniformly in all directions. Okay? Pairs of rows of antennas are often used to produce the desired radiation pattern. Okay? So ito yung itsura. Okay? Dahil physics tayo, we assume that the antenna is a point object. Okay? So ito yung dalawang antenna. They are spaced 400 meters apart. And now you can think of them as two slits. Okay, na kung saan galing yung waves dun sa two slits na yan. So you will have constructive interference patterns, okay, as a result of these two waves interfering with each other. Okay, you will also have destructive interference pattern. Basically, ang tinatanong is ano yung angle corresponding to maximum interference. Ang maximum interference ay dun sa m equals 0, m equals 1, m equals 2, and so on and so forth. Intindihan nyo? So kung maglalagay kayo ng plate dito, okay, maglalagay kayo ng plate dyan, okay, nasan yung ano yung angles that correspond to those positions on the plates na kung saan maximum yung interference pattern. Okay? Obviously, dito sa gitna, yan yung m equals 0. So you automatically, meron na kayo kagad na unang sagot, which is 0 degrees. Right? Again, mukhang hindi siya 0 degrees, di ba? Kasi isipin nyo, meron pang angle or pwede ka mag-form ng triangle dito. Again, tulad na sinabi ko, if it is very, very far away, you can assume that that's 0. Okay? Ano yung m equals 1 dito at saka m equals positive 1 dito at saka m equals negative 1. So, ano yung angle na nagko-correspond doon? So, if you, 30 kasi yun na yung nakasulat. Okay? And then yung susunod dito ay m equals positive 2 tsaka m equals negative 2. Okay? So yun yung essentially hinahanap. Okay? So paano natin i-solve yun? Well, syempre gagamitin natin ito equation na ito. Since hinahanap yung angles, then we start with this equation. Okay, this came from d sine theta equals m lambda. Okay, nandoon na yan sa notes nyo, I'm sure. Since we're solving for theta, okay, then ang gagawin na lang natin is m lambda over d. Okay, sabi natin ay m equals 0, yun yung central. So pag m equals 0, yung sine theta ay equal to 0, which means na yun yung first na interference, constructive, first na location ng constructive interference. So for m equals plus or minus 1, okay, m equals plus or minus 1, okay, then you will put here 1, anong matitira sa inyo? Lambda over d. Ngayon, ano yung wavelength ng radio wave? Sinabi na it is, ng frequency ay 1.5 megahertz. Tama? And since you know the speed of light, di makukuha nyo na yung wavelength. Right? Paano nga ulit sila related? C is equal to lambda F. So if you know F, and you know C, di makukuha nyo yung wavelength. And that's how they got 200 meters. Okay, so ilalagay na natin yung 200 meters dito. Alam natin na yung distance between the two antennas ay 400 meters. So, for m equals 1, ang lalabas ay m over, ang lalabas is 1/2. Tama ba? Ang lalabas ay 1/2. So, sine theta equals 1/2 is what? What is theta then? Ano ang theta pag ang sine theta equals 1/2? 30 degrees. Tama? Okay, which verifies yung pinakitang solution kanina. Okay, what about m equals 2? Pwede ka ba magkaroon ng m equals 2 dito? Pag m equals 2, ang matitira sa inyo ay 1. So ano ang sine theta equal to 1? Ano ang theta din? 90 degrees. Tama? 90 degrees. So, ibig sabihin, yung m equals 2 ay nandito at saka nandito. Okay, so, you will have high intensity, tawag dito, signal dito, dyan, at saka dito. Okay, pero no intensity or walang signal pag dito sa gitna, or dito sa gitna nila. Tama? Okay, which is good. Ngayon maintindihan niyo na kung bakit kayo nawawalan ng signal. Pag ito, dalawang antena at nandun katapat niyo yung antena, alam niyo na meron kayong signal. At ang lakas-lakas nung signal na yon. Right? Pero, kung umakyat kayo ng bundok, posibleng mawalan kayo ng signal kasi lumalapit kayo dun sa region ng destructive na interference. Okay? Naintindihan niyo? Okay? Of course, hindi lang yan ganun kasimple. Marami pang ibang factors kaya wala kayong signal, mostly dahil lang dun sa provider. Dahil walang kwenta yung ating mga providers. Tama ba? Okay. Okay, so ito naman yung angles corresponding to yung destructive interference. Okay, questions? Questions? Okay, ngayon, ang i-discuss natin ay intensity patterns. Okay, paano ba natin kinocompute ang intensity? Naalala niyo ba kung paano kinocompute ang intensity dati? Sa electromagnetic waves, pag given yung electric field, paano yung kunin yung intensity? Wala sa notes niyo? 1/2 times. Naalala niyo ba? Ha? Hindi, given yung electric field lang, paano niyo makukuha yung intensity? 1/2 times epsilon naught times, nalala nyo ba? O hindi na? Yan, di ba? 1/2 times epsilon naught times C times yung electric field squared. Right? Right? Okay, so yan yung ating equations. So babalikan natin yan ha. So magsisimula tayo ngayon dun sa electric field. Okay, in other words, yung dalawang rays, yung dalawang light rays na dinidiscuss natin kanina, express natin ngayon sila in terms of their electric field components. Okay? So, yung isa ay E cosine omega t. At yung isa is out of phase by phi. Okay? Yung pangalawa is out of phase by phi. Right? Right? Okay. So, paano natin ngayon kukunin yung intensity galing doon? Well, ang gagawin natin ay magdodrawing tayo ng dalawang electric fields. Dahil ang electric fields ay vectors, so ito yung E2, di ba? Kasi ito yung E cosine omega t, at ito naman yung E1, kasi ito yung E cosine omega t plus phi. Right? Di ba? Cosine omega, ito yung omega t, so ito yung cosine omega t. Tama? At ito naman yung E times cosine omega t plus phi. So ito yung omega t plus phi. So ito yung basically yung E cosine omega t plus phi. Okay, if you do trigonometry. Right? Okay, so ito yung E2 at yun yung E1. Okay? So, paano ba kayo nag-add ng vectors? Okay. Dito, ina-add nyo yung vectors graphically. Di ba? Pinagdidikit nyo yung buntot sa ulo, and then, para makuha yung resultant vector, i-connect nyo itong buntot nito dun sa ulo nun. Okay. Then you get the resultant vector. Okay. Mathematically, anong law ang gagamitin ninyo para makuha ito? Cosine law or sine law? Kasi alam nyo ang omega t, alam nyo yung phi. Ibig sabihin, alam nyo ito, alam nyo yun, di ba? Alam nyo rin yan, di ba? Right? So, ang gagamitin nyo? Cosine law. Tama? Tama? So, alam nyo na lahat yan. Of course, if these are vectors, then you just break them down into components. So, meron kang x component, i-add nyo yung dalawang x components. Meron kayong y components, i-add nyo yung dalawang y components. Tapos, yung resulting vector ay makukuha nyo from the sum of the squares of the components. Tama ba? Tama? Okay, so meron tatlong paraan para gawin yon. Okay, what you will get is 2e, absolute value ng cosine phi over 2. So, EP is equal to 2e cosine phi over 2. Okay, so dito yung derivation, okay, pero hindi na natin kailangang i-discuss yan. It's very straightforward. Ang ginamit niya lang dito is cosine law. Okay, so once you get this expression, then you plug that expression in sa equation na ito. Okay, which is equation for the intensity. Okay, and pag pinasok dito yung cosine, ano na nga yun? E naught cosine phi over 2, tama? So, E squared cosine squared phi over 2 kasi ito ay EP squared. So, ang lalabas for the intensity is this value, 2E C E squared cosine squared phi over 2. Okay, tapos, kung gagamitin natin ito as I naught, okay, so i-define natin ito as I naught, then we get this very simple expression for the intensity, which is I is equal to I naught cosine squared phi over 2. Okay? So from here, makukuha na natin yung intensity ng interference pattern. Ang kulang na lang dito is ano yung phi? Ang phi is yung phase difference between yung angle, between yung E2 at saka E1. Okay? As represented by this figure. Okay, so ito yung E2, ito yung E1, at yung phase difference nila ay 5. Nasunod? Nasunod? Okay. Questions? Wala? Okay, sige. Break muna tayo dahil pagod na kayo. Wala na kayong energy para tumango o umiling. So, 10 minutes.